So this is tiling, 2D tiling of packaging for cigarettes, which is about 6 centimeter wide. And here we created a map. So I can here use this map to go to different places. For example, I can click here to the here, and we will come to this place. And here we have some very fine lines that are transparent and quite difficult to measure. And I would like to scan them using the nanopoint scanner. So what I will do is I will go to the coordinate capture, and I will add this as my starting point, and then I will go maybe up to here. And I will save this and call it position 111. Okay, and now I will go to the nanopoint scanner, and this is my ends, and I will load the point number 1. I will go there, and I will choose this as my starting point, and now I will press on scan profile. So now the sample goes under the nanopoint scanner, and here we can directly scan the surface. I can here do the auto leveling and then choose to measure the height. Here we have 12 microns height difference on this transparent sample. I can also measure distances. For example, from here to here we have 5.7 millimeter, 5,745 microns. And then I can of course also go to mountains map if I want to do further analysis. In this case I want to measure step height, so I can click on height measurements, and then we can do a little overview of those steps. So now mountains map is opening, and we can see here the profile, and automatically it has been already processed a little bit with a little filter and leveled as well. And here we can see for each of the steps, here we have about 10, 7, 8, 10, 10, 12, which is the one I calculated now, 10, 11, and so on. So here we have the height measurement of all those steps. And now instead of scanning a profile, I will scan an area, so our surface. I will choose my starting points here, and then I will choose here my end points somewhere here, and we will do 50 lines, which will take about 3 minutes. Now we can see the scan being generated at quite a fast speed, and after 50 lines we will look at the results in 3D. And this is the result after 3 minutes of scan. So we have a fast and accurate profile on 50 lines. However, we don't have a very high resolution in the y-axis, as here the 50 line is quite far apart. The measurement here is correct for each of the line, and if you want to have a higher resolution, then you can do for example 250 lines, which looks like this, and it has much higher resolution in X, Y, and Z. Z has no changes, but the X, Y here has been improved, mostly the Y. And then from this you can do further measurements, and again here you have the automatic stepped heights that are generated.